Let's jump right into this explainer. We're looking at one of the most fascinating mysteries in all of astrophysics, hunting down the origins of the most energetic particles in the universe. We'll be breaking down a paper titled Ultra-High-Energy Cosmic Ray Origins, a testable candidate taxonomy and ranked nearby source list. It's essentially a cosmic detective story, and we're going to see exactly how scientists are trying to crack the case.
So we have to start with the ultimate question about these elusive particles striking Earth from deep space. Where do they actually come from? And, why has finding their exact source been so incredibly difficult for scientists over the last few decades? We know for sure they hit us, but tracking their flight path back to a specific galaxy, well, that's been a massive challenge.
Here's our agenda for today. 1. The cosmic ray mystery. 2. Kevin L. Brown's hypothesis. 3. Ranking the nearby suspects. 4. Testing the theory. 5. How to prove it wrong. And finally, 6. Real-world implications. Let's get to it.
Starting with Section 1, the cosmic ray mystery, a trail gone cold.
First things first, let's define what we're even looking for here. Ultra-high-energy cosmic rays, or UHECRs, are basically just charged particles, often protons or atomic nuclei. But what makes them so special is they're traveling across the universe at nearly the speed of light, packing absolutely unimaginable energy. We're talking about a single microscopic particle hitting the atmosphere with the kinetic punch of a fast-moving baseball. Just incredible.
And this brings us right to the core problem. Because these incredibly fast particles carrying electrical charge, magnetic fields out in deep space actually bend their paths. So by the time they reach Earth, their trajectory is totally scrambled. It's literally like trying to guess who shot a pinball after it just bounced off 100 different bumpers. You just can't trace a straight line back to the source.
Moving on to Section 2, Kevin L. Brown's hypothesis, organizing the suspects.
Now, this framework comes straight from researcher, inventor, and author Kevin L. Brown. His 2026 paper outlines a really brilliant working hypothesis to stop guessing and start systematically organizing and ranking specific space systems. He essentially realized that since we can't trace the exact path, we need to look at the whole universe of possibilities, group them into a limited set of suspect types, and test them rigorously.
The crucial point here is a major shift in thinking. The old way of doing things, that was just guessing, broad, generic space phenomena. Scientists would say, well, maybe they come from generic space shocks or jets. But the Brown framework is a real game changer. It creates a highly structured, testable list of actual, named galaxies right in our cosmic neighborhood. It takes us from vague ideas to a highly specific lineup of suspects.
What's really fascinating is Brown's 6-type classification system. It beautifully organizes every single potential cosmic accelerator into specific groups. You've got giant radio galaxies in Type A, starburst galaxies in Type B, all the way down to local anomalies in Type F. So instead of an infinite number of random guesses, we now have a clean, organized table of exactly what kind of galaxy might be shooting these particles at us.
Section 3, ranking the nearby suspects, the cosmic lineup.
Ranked at the absolute top of the list, our Tier 1 prime suspects are Centaurus A and Fornax A. And why are they at the top? Well, it's because they're relatively close by, and they have these massive magnetic structures called lobes that are actually capable of holding and firing these extreme particles. Plus, they have a known history of huge energy releases. They've got the motive, the means, and the opportunity. But, a good detective doesn't just look at one suspect. We also have a secondary lineup of backup suspects to test against, like M83 and M82. We've got a weird anomaly candidate in the Large Magellanic Cloud, and critically, there's a vital control candidate, M87. Now, M87 is this huge, powerful galaxy that looks like it should be guilty, but strangely lacks a strong cosmic ray signature. Testing against M87 is absolutely crucial to prove our ranking system actually works.
On to Section 4, testing the theory, the interrogation protocol.
So every suspect galaxy has to pass this really strict 3-step physical sequence. Step 1 is containment. Can the galaxy's magnetic field physically hold on to the particle long enough? Step 2 is acceleration. Can it rapidly transfer unimaginable energy to that particle before it breaks apart? And Step 3 is escape. Can the particle actually survive that incredibly violent environment and shoot out into deep space toward Earth? If a galaxy fails even one of these steps, it's crossed off the list for good.
Section 5, how to prove it wrong, establishing the failure criteria.
A good scientific framework has to be falsifiable, right? There have to be strict rules for failure. For instance, if the framework can't logically separate our prime suspect, Centaurus A, from that M87 control candidate, the hypothesis entirely fails.
Or if the model requires scientists to secretly tweak the data after the test just to make it look successful, total failure. Setting these strict rules up front is what makes this real, rigorous science.
Let's look at Section 6, Real-World Implications. Case closed? The main takeaway here is just huge for astronomy. Science finally has a structured, testable blueprint to stop guessing blindly. Astrophysicists now have a clear, bounded roadmap to confidently narrow down exactly where these high-energy particles are born. This is going to save time, it's going to save precious telescope resources, and it points us directly at the very best targets. I want to leave you with this final thought today. As you think about the absolute vastness of space, ask yourself, if Centaurus A truly is our prime suspect, what incredible, violent secrets are its massive magnetic lobes hiding, just waiting for future telescopes to uncover? The universe is constantly firing these invisible bullets at us, and thanks to this explainer, you now know exactly how scientists are hunting down the shooter.